All right, pre-algebra students, let's take a look at our first chapter of the year. We're doing chapter 1. This chapter is called Tools of Algebra, and we're looking at section 1, Words and Expressions. Begin by considering some vocabulary that we should be familiar with. However, let's make sure that we know what we're doing. So the first we'll talk about is numerical expression. A numerical expression is simply a numerical sentence that contains a combination of numbers and operations such as addition, subtraction, multiplication, and division. Please check out the examples that we have. So we've got 3 plus 5 minus 7. 4, if you notice here, when there's no symbol given and we have a number next to another number in parentheses, that's just multiplication. So 4 times 3 plus 2, and 6 divided by 2 minus 9. Notice that there's no equal sign here. That's something different when we have an equal sign with a bunch of numbers and operations. Our next word is to evaluate. When you evaluate an expression, you're really just finding the numerical value. You're finding its numerical value. And finally, one that we all should be familiar with, order of operations. Parentheses, exponents, multiplication and division, and that's from left to right, and similarly addition and subtraction from left to right as well. So we've got that going on. But there's one other piece that I want to kind of bring to mind when we think about order of operations. Parentheses really could be called any sort of grouping symbol. And grouping symbols could be parentheses, as we know. It could also be brackets. And in a way, we'll see in a few examples, a fraction bar tends to be a grouping symbol. So if I had, let's say, 6 plus 2, and then 4 at the bottom, 6 plus 2 over 4, that really means 6 plus 2 first, then divided by 4. And we'll talk about that later. Our first example gives us the opportunity to translate phrases and expressions, or translate phrases into expressions. So if we take a look here, we're to write a numerical expression for each verbal phrase. So the verbal phrases that follow, A, B, and C, the first one is the total amount of money if you are given $9, then $12. I think most of you probably did the math in your mind and did 9 plus 12, and you got the answer 21. Really, when you're asked to write a numerical expression, you just want to write 9 plus 12. We haven't been asked to evaluate it, so that's all you need to do there. B, the age difference, this is a key word, between a 45-year-old and a 73-year-old. Difference means means to subtract, or it means the difference between two things. So generally we know that that's going to be subtraction. 73 minus 45 is going to be our answer. Again, you do not have to evaluate, just write an expression. C, the amount of calories in 7 donut holes if each has 75 calories. Each has 75 calories. We've got 7 of them. The idea here is to recognize that this is a multiplication problem. So 75 times 7. Finally, the number of groups created within a classroom of 21 students, where each group has 3 students. So how many groups would we have? Well, if we take 21 and we divide them into groups of 3, we'd get our answer. In the second example, we're going to evaluate each expression, and we'll have a few expressions to do so. The first one is 20 minus 3 times 6. As we know, we are thinking about please excuse my Darren Sally, or parentheses, exponents, multiplication, division, addition, subtraction. We know that we've got to do this first. So our answer here is going to be 20 minus 18, which gives us 2. Along with our next example, I also took the liberty of writing down, this mnemonic device, PEMDAS or PEMDAS, or parentheses, exponents, multiplication, and division. It's really necessary for us to remember that multiplication does not supersede division. In fact, in a problem like this, we need to make sure and just go from left to right, not do multiplication first, but since it's only multiplication and division in the problem, we're going to just go from left to right. So 30 divided by 5 gives me 6, and then 6 times 3 gives me 18. Example C, we've got 4 times the quantity of 10 minus 7. When there's no sign given, we know that's multiplication. 4 times the quantity of 10 minus 7 plus 2 times 3. Whole lot going on. Let's take it in order. Let's deal with PEMDAS. So we have parentheses first. So that tells me I'm going to rewrite this whole thing as 4 times 10 minus 7 is 3. So instead of having 10 minus 7, I've replaced that with 3, and then everything else comes down. The next thing I'm going to do is refer to, the order of operations. From left to right, I've got to do multiplication and division first. There's no exponents. I've taken care of the parentheses. So from left to right, I'll get 12 plus 6. Notice I replaced 4 times 3 with 12 and 2 times 3 with 6. Then I go ahead and add the rest, and I get 18 again as an answer. Only 2 more examples in this section to go. Let's look at this one, D. We've got 5 times the quantity of, and let's make sure I have that right. I think there's a bracket that goes here. 5 times the quantity of all of this stuff, and the stuff is 11 minus the quantity of 7 plus 5 divided by 4. So we need to also unpack this. Again, notice that we have this grouping symbol of the bracket. So we need to deal with the bracket first. And the 5 is the only thing outside of the bracket. So the 5 will obviously be multiplied later on. So what I'm going to do is go straight to the center of this problem. Inside of the bracket, I have a pair of parentheses. I need to deal with that. So when I rewrite this problem, I have 5 times the quantity of 11 minus, instead of writing 7 plus 5, I'll write 12 here because that's what 7 plus 5 is, divided by 4. And I'll close my bracket out. I'm still dealing with my bracket, and what I need to do now is again consult my order of operations. I'm not going to subtract first. I'm actually going to divide because division supersedes subtraction. 12 divided by 4 will give me 3. So here's my 3, and 11 minus 3 is what I have here. And I'm going to put that in the bracket, have 5 on the outside. Let's now take care of the subtraction. 11 minus 3 is 8. And when I multiply 5 times 8, as I'm asked to do here, I'm left with 40. My answer to part D is 40. Okay, so we have reached the last part of example 2, but not the last example. We've got one more example, example 3. But right now, example 2, part E, we have a fraction. But we talked about the fraction bar as somewhat of a grouping symbol. So when we see this, you should think, I'm going to do a little thought bubble here. You should think of this as 60 minus 15 in parentheses divided by, let's see if I can fit this here, 2 plus 7, close parentheses. And that's what we're thinking about, and that's exactly what we'll do. So I'm going to deal with 60 minus 15 first. And 60 minus 15 is 45. In the denominator, I'm going to deal with that. 2 plus 7 gives me 9. And write this here. 45 over 9 is equal to, same thing as 45 divided by 9 is 5. And that's our answer. Our next problem is a real-world example. We have a cell phone company that charges $20 per month and 15 cents for each call made or received. Write and evaluate an expression to find the cost for 40 calls. Then make a table showing the cost for 40, 50, 60, and 70 calls. Well, first let's kind of unpack this a little bit. We recognize, and I'm actually going to add a little bit of a clarifying detail. I believe that they intended, I copied this right out of your text, I believe that the intention was for these 40 calls, and when we look at the other number of calls, all of that to be made within the 1 month. So let's look. A cell phone company charges $20 per month. That seems to not indicate whether or not you've made 1 call or 0 calls. You're going to get charged $20 a month. And then in addition to that, 15 cents per each call. So then we're going to write an expression and we're going to evaluate how much would it cost for 40 calls to be made during that month. So we know that there's a $20 fee, and then we're going to add to that the cost for each phone call. So that's going to be 15 cents. But if we make 40 phone calls, that's going to be 40 times 15 cents. We can apply, so since we're going to evaluate this, we could also apply our skills with the with the order of operations and do 20 plus 15 plus 0.15 times 40, recognize we've got to do multiplication first. So this ends up being 20 plus 0.15 or 15 cents times 40 gives me $6, and my final answer is 26. Okay, so we want to answer the second question, which is to set up a chart or a table showing the costs for these other values. So if you notice here, we've already inputted what we knew about 40 calls. We did 20 plus 15 cents times 40 gave me 26, and we'll do the same for each of the following. Looking at this expression, we can see that the cost for 50 calls would bring us to 20 plus $7.50. That's what 15 times 50 is, because we've got to do the multiplication first. When we add it together, we get $27.50. For 60 calls, we've got 20 plus the quantity of 15 cents times 60, which we know to be 9. And so we get $29 for that call. And finally, 20 plus 15 cents times 70, which gives us $10.50. So we recognize that this last cost for 70 calls would be, according to this phone plan at least, would be $30.50. And let's put some dollar signs here. And we're done our examples for your assignment tonight. You should certainly look at pages 8 through 9. You are going to be responsible from this lesson for the following problems: 12 through 29 all, and 30 and 32. Finally, I'd like you to try some of those hot problems. They're on the next page. They're on page 9, and you only need to do 2. I'll let it be your choice. Guys, have a good one. Make sure you have some questions. Make sure your notes are in Cornell form. Thanks.